Okay, hello everyone. In a new video, so we have reached part 2 of chapter 4, which is the chapter of mechanical actions for grade 8 students. And eventually we have reached section number 3, which is the representation of a force. Then let me write section number 3, representing a force. So let me write here that the force is represented using a given scale in centimeters. Okay, and hereby representing, I mean drawing a force F. So let's consider the following example. Now, in order to represent the force, first we need to consider the properties of the force. So let me consider the following example and say represent a force F having a point of application A line of action vertical the direction is upward and the magnitude is 30 newtons. Use a scale of 1 centimeter corresponds to 10 newtons. So now we need to represent this force F having the following properties: that the point of application is A, the line of action is vertical, and the direction is upward. The magnitude of this force is given by 30 newtons. And I repeat, by represent, it means that we need to draw. So here first, in order to represent this vector, we need to determine the length of this vector because our rulers are graduated by centimeters and not by newtons. So here the magnitude is given by 30 newtons. So we place 30 newtons under 10. Then in this case, what is the length of this vector? Now we cross multiply 30 multiplied by 1 divided by 10. So this is equal to 3 centimeters. Then the length of this vector is given by 3 centimeters. So let's consider the point A. Then we represent this vector according to these properties. We have the point of application A, the line of action is vertical, and the vector is pointing upward. What about the magnitude? The magnitude is related to the length by 3 centimeters. So it's pointing upward like this. So this is the vector F. The length of this vector is given by 3 centimeters and its magnitude is given by 3 newtons. So now each division here represents 1 centimeter. Okay, so these lines, in order to indicate that the length of this vector is given by 3 centimeters. So now let me move to the following activity found in page 78. They are telling me a person pulls the hook of the spring balance Recall that the spring balance is an instrument that measures the magnitude of the force. The spring scale indicates 3 newtons. Now, why the spring balance is indicating 3 newtons? Although here the needle is pointing at 30. But notice that on the spring balance there is a scale. So there is multiplied by 0.1. So in this case, 30 multiplied by 0.1, so this is equal to 3, and the unit here is given by in newtons, okay? Now they are telling me specify the characteristics of the force exerted by the hand on the hook. So this is the hand, and this is the hook. This is the hook. We need to represent the characteristics of the force exerted here, which is like this. Now, what is the point of application is A. What is the line of action? Recall that this is the horizontal and this is the vertical. Now the direction is the right. As for the magnitude, it's given by 30 times 0.1, which is equal to 3 newtons. Now they are telling me the length L of the force vector is proportional to the magnitude of the force. Okay. So they are telling me represent the force vector that corresponds to the action in document 19. So we need to represent this force of the following properties. A, horizontal, right 3 newtons. Using the scale, each 1 centimeter corresponds to 1 newtons. So in order to represent a vector, we need to determine the length of the vector, because recall that our rulers are graduated by centimeters and not by newtons. Knowing that each 1 centimeter corresponds to 1 newtons, what about 3 newtons? It corresponds to what? Then 3 multiplied by 1 divided by 1. So this is equal to 3 centimeters. Then the length of this vector is given by 3 centimeters. Moreover, we need to represent, which means we need to draw. So this is the point A. This is the vector force. So let me say that this is F. The magnitude of this force is given by 3 newtons and the length is given by 3 centimeters. So this is it for this activity. Now let me move to activity number 1, page 79. So they are telling me represent, and by represent it means that we need to draw, using the scale 1 centimeter correspond to 10 newtons, the following forces. So we need to draw the force F1 of magnitude 15 newtons and applied at point A horizontally to the right. So the force F1 must be something like this, horizontally to the right, but now we need to determine the length of this force, and this can be done by using the scale and the magnitude. So knowing that each 1 centimeter corresponds to 10 newtons, the magnitude of this force is given by 15 newtons. Then its length is given by 1. If we cross multiply here, 15 multiplied by 1 divided by 10. So this is equal to 1.5 centimeters. Why centimeters? Because this is under centimeters. So the length of this vector is given by 1.5 centimeters. Now we drag the ruler. So this is 1 centimeter and this is 0.5 centimeters. So this is the force F1 of magnitude 15 newtons and length 1.5 centimeters. Now as for the second force F2, they gave me the properties. So it's being applied at the point B vertically upwards, so it's something like this. But now we need to specify the length of this vector, knowing that its magnitude is 20 newtons, and we are representing this vector using the scale 1 centimeter corresponds to 10 newtons. So 1 centimeter corresponds to 10 newtons. 20 newtons corresponds to what? So now if you cross multiply, now we have placed the 20 newtons. Okay, 20 newtons is being placed here because it is under newtons. Now 20 multiplied by 1 divided by 10, so this is equal to 2 centimeters. So the length of this vector is given by 2 centimeters. So it's being applied at the point B vertically upward, and the length of this vector is 2 centimeters. And now as for exercise number 6, page 85, they are telling me force representation. A person is pulling a load through an extensible string as shown in the adjacent figure. 6.1. What are the characteristics of the force F exerted by the wire on the hook? So this is the force. Knowing that the magnitude of this force is 30 newtons. So the properties of the force F are given by the point of application, the line of action, the direction, and the magnitude. So in this case, the point of application is C, the line of action is horizontal, the direction is to the right, and the magnitude is given by 30 newtons. And recall that always whenever we need to list these properties, we need to list them in this order: P, L, D, and M, which is given by the building. Okay? Now in 6.2 they are telling me represent this force using the scale 1 centimeter for 10 newtons, and by represent it means that we need to draw. So now each 1 centimeter corresponds to 10 newtons. We need to draw the force vector corresponding for 30 newtons. Now we place in newtons under in newtons, so this is 30 newtons. It corresponds to which length? Then 30 multiplied by 1 divided by 10, this is equal to 3 centimeters. So the force F will be 3 centimeters here along the string. So this is the point C. This is 3 centimeters. And of magnitude 30 newtons, okay? Now as for number 7, pages 85, 86, they are telling me characteristics of a force. Now recall that this instrument here is a spring balance that measures the magnitude of a force. They are telling me a spring balance measures the magnitude of a force exerted on point A as shown in the adjacent figure. Now in 7.1 they are telling me calculate in a Newton the magnitude of this force. And by calculate it means that the answer of this part involves calculation. Now the magnitude can be determined by referring to the indication of the spring balance. Notice that it's indicating 40. So the magnitude multiplied by the indication. So always whenever we are taking data we need to multiply. So here we have multiplied by 0.1, so this is equal to 4 in newtons. So the magnitude is given by 4 in newtons. So this is the magnitude of the force which is expressed in newtons, and recall that the spring balance always measures the magnitude of the force. Now in 7.2 they are telling me what is the length of the force vector F shown in the figure, and the length can be measured using the ruler. So notice that here the length of the vector is given by 2 centimeters. So the length is simply given by 2 centimeters. Now they are telling me in which scale is the force drawn. So here by the scale, it means that we need to write or to answer the relation between centimeter and the newtons. So for example, this is a scale, this is a scale, so all of these are scales, okay? So how we will determine the scale? Notice that for the same force, 4 Newton corresponds to 2 centimeters. So this is a scale. Okay? But moreover, the scale must be expressed in a unit of length which is not 2 but 1 centimeters. So how do we convert this into 1 centimeter? Simply we divide both sides by 2. So this is the scale. I repeat, the scale is a relation between centimeters and the newtons, and making sure that this number must be equal to 1. Okay? How I have determined that the relation between centimeters and newtons are 2 by 4 is that we know that for the same force the magnitude is force and the length is 2. Now in 7.5, here there is no 7.4, there is no missing part, this must be 7.4. Let's say that this is 7.4. They are telling me complete the table by including the characteristics of F. So notice that the point of application of F is A. Let me write them here. And notice that they are listing these properties in this order: P, L, D, M. So in this case, the line of action is vertical. The direction is in this case pointing. So the direction is determined from the pointing of the arrow, which is downward. And the magnitude in this case is given by 4 newtons. Okay. Now let me move to the final exercise of this video, which is exercise number 8, page 86. Now they are telling me representation of an oblique force. So notice that the title of this exercise is very important. Here oblique represents the line of action of this force. So the force included in this exercise has a line of action which is oblique. A person is pulling a sleigh on snow by using a rope as shown in the figure. The rope exerts a force of magnitude 200 newtons. So the magnitude of this force is 200 newtons on the sleigh and makes a 25 degrees angle with the horizontal. Now in 8.1 we need to write the characteristics of F. In order to determine the characteristics of F, we need to refer to the figure and to check how the rope is exerting an action on the sleigh. So notice that the person is pulling the sleigh along this direction, so this is the force which causes the motion of the sleigh from right to left along the snow. Okay? So what are the properties of this force? The point of application is B. The line of action is oblique, which reflects the title of this exercise. The direction is upward to the left, so upward to the left. And the magnitude is being stated here, which is given by 200 newtons. Okay? So the point of application is the point B. The line of action is oblique. The direction is upward to the left, and the magnitude is 200 newtons. Okay? Now in 8.2 they are telling me represent this force using the scale 1 centimeter for 100 newtons, and by represent it means that we need to draw. But notice that we will draw using a ruler, and the ruler in general is graduated by centimeters and not by newtons. So in order to represent this force, we need to know the length of this force in addition to the magnitude, to these properties. So knowing that each 1 centimeter corresponds to 100 newtons, what about 200 newtons? It corresponds to what? then 1 multiplied by 200 divided by 100. So if we cross multiply here, okay, 200 multiplied by 1 divided by 100, this is equal to 2 centimeters. Now after we have determined the length of this vector and we know the other properties, we can represent this force. So this is the point B. The force F vector is represented upward to the left oblique, and here we need to make sure that the length of this vector is 2 centimeters, worth of 200 newtons according to this scale, and the name of this vector is F. Okay, so for sure that this angle here with the horizontal is given by 25 degrees. So that's it for me in this video, guys. In the next part we'll complete solving exercises on this chapter.